Ladies and gentlemen, welcome to you virtually from every time zone around the world. My name is Gabriel. I'm from the MAS, and I will be your host and MC for this year's Global CBDC Challenge as part of the Singapore FinTech Festival 2021. Now, CBDCs, as we are aware by now, has the potential to increase payment efficiencies and financial inclusion, while supporting the broader digitization drive in the economy. Now, some background of the challenge. As such, we took the initiative to launch the Global CBDC Challenge in partnership with 8 worldwide organizations. We've got the International Monetary Fund, World Bank, Asian Development Bank, UN Capital Development Fund, UN High Commission for Refugees, UN Development Program, and the Organization for Economic Cooperation and Development. Now, this initiative is hosted right here by MAS and is powered by Tribes, Singapore's very own blockchain ecosystem builder. The objective of this challenge seeks innovative retail CBDC solutions in 2 key areas: enhancement of payment efficiencies and the ability to promote financial inclusions. Now, today we've got the top 15 finalists on view, and they have all been selected from more than 300 proposals from over 50 countries around the world. Now, these 15 teams will then be cut down to 3. Just 3 winners who stand a chance to win $50,000 in prize money each. Well, these 15 all have been given the opportunity for an MAS-driven grant, now worth $200,000 each. And this would not be possible, and it's also my great pleasure to introduce our panel of 8 esteemed judges. First and foremost, from the International Monetary Fund, we've got Tobias Adrian, who's the Director for Monetary and Capital Markets Department. From the World Bank, Jean-Denis Pesme, Global Director, Finance, Competitiveness and Innovation. From the Bank of International Settlements, we've got Benoit Corre, Head of the BIS Innovation Hub. From the Reserve Bank of India, we've got Sri Vasudevan, Chief General Manager, Payments and Settlements. From the Central Bank of Kenya, Dr. Patrick Njoroge, he's also the governor. And then we've got also the Central Bank of Brazil, better known as the BCB. We've got Dr. Marcelo Madureira Prates, who is the General Counsel's Office Chief of Staff. And then we've also got from Harvard University, Professor Kenneth Rogoff, Thomas D. Cabot, Professor of Public Policy and Professor of Economics. Last but not least, we have from Bank of Indonesia, Langshish Hendrata, Assistant Governor, Head of Payment System Policy Department. Welcome, everyone. Now, the judging criteria will take into account these following things: product, pitch, feasibility, impact. These are all the key things. Now, for the rules, very quickly, 5 minutes duration for each pitch, 3 minutes for judges' questions. Without further ado, ladies and gentlemen, now we begin. And introducing to you the first team, here we go. First up, let's invite the team from ANZ. ANZ, over to you.
Hello, everyone. We believe a central bank digital currency ecosystem must make best use of existing resources and offer a layer for continuous innovation. We present to you National Integrated CBDC Ecosystem.
Our citizen-first solution has been created to address inclusion and improve the financial health of society in an increasingly digitized economy. Universal accessibility of CBDC is achieved by making its distribution a public good, delivered in partnership with the private sector. The National Integrated CBDC Ecosystem, or NICE, consists of 3 key components. The first, a digital token-based currency issued by the central bank. The second is the government-operated Prime Wallet layer, which is the core distribution mechanism of the CBDC. This wallet is issued and identified using the National Digital ID. The third component represents an innovation layer in the form of secondary wallets, provided by regulated commercial operators. Starting with Cbdc Issuance, the prototype uses eCurrency's solution to implement CbdC as digitally signed cryptograms, which are issued and monitored by the central bank. With regards to distribution, the solution features a government-operated Prime Wallet, which is authenticated through SingPass in our prototype. This forms the basis of nationwide access to the CBDC without the need for additional onboarding. Let's consider Sophia, who does not have a bank account. The government can send medical aid directly and securely into Sophia's Prime wallet, accessible via her smartphone. At the pharmacy, Sophia attempts to pay for several items. However, her Prime wallet has been programmed against a designated use, so she can only use the aid to purchase medication. Upon purchase, funds are received instantly into the pharmacy's Prime wallet. Additionally, our prototype features offline cards, which are linked to Prime wallets. Offline cards enable two-way fund transfers using near-field communication. NFC enables devices with digital wallets or special-purpose CBDC kiosks to interface with offline cards for both transactions and wallet administration. This capability has been designed for circumstances when internet connectivity is unavailable and safeguards against double spending through secure on-card processing and subsequent validation. Our solution delivers a distribution system with extensive functionality. This robust, digitally enabled Prime wallet infrastructure improves the efficiency and effectiveness of payments between the government, individuals, and businesses. Finally, for the secondary wallet infrastructure, we recognize that banks and other commercial operators play a crucial role in enriching the digital ecosystem. By developing proprietary secondary wallets linked to Prime wallets, commercial operators can offer value-added services to meet the diverse needs of their respective customers. Consider Amit, who uses his bank wallet to make a cross-border payment. He initiates the transfer using his bank wallet, which facilitates instant token-to-account convertibility. This connects with the Mojaloop system, allowing Amit to send money to his friend in the Philippines. Secondary wallets enable functional interoperability between traditional and non-traditional payment rails. This promotes the adoption of CBDC into the payments landscape while strengthening personal data sovereignty. Commercial operators can choose their preferred technology without compromising on interoperability. Here we see Amit using a secondary wallet on blockchain. Open source technology and open APIs can fulfill integration and value transfers across the end-to-end ecosystem. This is showcased through these 4 different secondary wallets. A public payment framework like NICE supports extensibility and innovation driven by competition among commercial operators, fostering new ideas, approaches, and opportunities for CBDC use. ANZ's purpose is to shape a world where people and communities thrive. We believe that a considerately designed CBDC using public-private infrastructure can work to deliver a more accessible and inclusive future where people are empowered through digital solutions.
To summarize, our solution makes efficient use of existing infrastructure to create an interoperable and resilient CBDC ecosystem. We also believe it creates financial inclusivity and accessibility. We welcome any questions.
All right. Thank you, ANZ. Judges, time for questions, and please don't forget to enter the scores. Judges, if you've got any questions, please unmute your mic, raise your hand, ask a question, please. You've got 3 minutes.
Yeah, I'll go in fast. Thank you for the presentation, Hari and team. Just wanted to understand what will happen to any user or jurisdiction which doesn't have a national ID in place. Is it not accessible? Is CBDC not accessible to them? I just wanted to hear from you about this.
Sure. Inga, do you want to take that question, please?
Absolutely. So the design principle of the model is to link the government-provided Prime wallets to a person's ID. Now, the most seamless implementation of this principle is linking digital wallet to digital ID. However, the same principle can be absolutely maintained in countries with the non-digital national IDs, or even using alternative unique identifiers that are available to every person in a country. Having said that, ANZ team strongly believes that digital ID is an important component of our increasingly digital society. So we think that linking the core CBDC distribution to a national ID, that could be an important catalyst for countries to advance their efforts towards developing a digital ID.
I think Dr. Patrick has a question. Just take note, we've got a minute,
Yes.
minute and 30 seconds left.
Yes. So you are trying to have all-inclusive, universally accessible system, and you're using the digital token issued by the central bank. Will this run also on feature phones?
Can you repeat the last piece? Will this run also on future?
Will this technology be operable on feature phones as opposed to smartphones? I mean, given the technology that you're using.
Understood the question. Thanks for that. Ignesh, do you want to pick that up, please?
Yes, so the design in our prototype we have shown using smartphones, but certainly any phone with near field communication technology can access, for example, the offline smart cards. And there are feature phones available today from companies like Nokia that have near field communications built in. So the smartphone is a good option to have, but certainly in countries where there isn't that capability, you can have kiosks available to use the offline cards or connect with the feature phone set as well.
Very quickly, 20 seconds left. One last question, one very quick answer from either Ibu or Data. Yep.
Yeah, okay, thank you. My question is, as a CBDC unit are issued again the designated denomination such as a serial number, do you think it will limit the performance of CBDC to the public?
I apologize. Time is up. We unfortunately can't take that last question. Do apologize. We unfortunately have to move on to the next team just to keep with the time, to be fair to everybody. Next, everyone, let's invite the team from Soremitsu. Soremitsu, over to you.
Like Soremitsu, several of our judges and many of the participants are deeply involved in financial inclusion. And today we will offer a glimpse on how CBDC data can revolutionize loan underwriting, especially in emerging markets. What's more, it can not just preserve, but enhance user privacy. Specifically, our solution answers statement 7 by triangulating propensity to pay using simple queries under conditions of data minimization and informed consent. Our solution is designed as an overlay application for our CBDC system, which is actually market ready. At the core of our CBDC system is Hyperledger Iroha, a blockchain operated by the central bank. Commercial financial institutions keep settlement accounts with the central bank, which are interoperable with core banking. Retail users onboard via FIs, which are responsible for wallet services, so it is a two-tiered architecture. The core blockchain, Iroha, records both retail and wholesale transactions in real time and also operates as a backbone ledger linking existing payment rails. This is important for our MAS solution because payment data across platforms can be integrated and analyzed. We implemented a variation on this system in 2019 for the National Bank of Cambodia called Bakong. In this variation, FIs pre-fund their digital currency accounts using their central bank reserves. Bakong links all legacy payment rails and inscribes all retail and wholesale transactions in real time on a single NBC-operated blockchain. Cambodia went the reserve-backed digital currency route for legislative reasons. If they wanted to ramp up to a direct CBDC minted on the blockchain, our system would allow it. But as is, Bakong has already performed well. Okay, let's move into the demo. The solution we'll demo today could overlay our CBDC system or an RTGS Plus system like Bakong. Our participants are a loan applicant and a lending institution. Also on the back end are a credit bureau, which designs the queries, and a central bank, which operates the ledger. Retail users onboard the CBDC system using a Soremitsu designed app. A user can register a limited wallet using just a domestic phone number. However, to access higher limits or financial services, the user must pass KYC at the FI that hosts their wallet. First, they take a selfie video, and then they photograph their ID. And optical character recognition fills in the customer info. Here we can mention that transactions are written on the blockchain using an anonymous wallet ID, whereas personally identifiable information is kept by the host bank. And this segregation of data preserves privacy. Okay, we are registering and should be able to transact soon. And once we're registered, let's imagine that our user goes to a microfinance institution to ask about a loan. This does not need to be the institution that hosts the wallet. So here we see the financial institution interface. During the interview, the user gives the FI their personal ID and their account ID. And the financial institution can then create a request, input the user's ID, and query the ledger for data relevant to the loan request. The queries are all Boolean, true, false, and defined in advance by a credit bureau. And the FI can input parameters suitable to the loan request. So some examples are minimum account balance for a variable number of months, inward payments from unique addresses to ensure a stable income, outward payments to unique addresses, for instance in the case of existing loans, payment volume, which is useful for MSMEs, and KYC status at the institution that hosts the wallet. Replies are always true-false. They don't reveal underlying transactions, so the data have little relevance outside the query and cannot be used to build a commercially exploitable database. So here in our end user app, we see that the user gets a permission request. They can check what data are queried. And once the user provides permission, then the financial institution instantly gets a data snapshot. And as you can see, the status has changed from pending to approved. And the underwriter uses this snapshot to help assess creditworthiness. In this case, the responses are all false, and this is because the wallet is brand new. And so our next steps for the system include refining functions for end users, credit bureaus, and the regulator, with a focus on inclusion, oversight, and financial literacy and health. For example, in our user's case, we could include nudges to good financial behavior that would help build a data history that's usable by lenders. So let's move into the Q&A. We look forward to your feedback both on our CBDC system and on our MAS underwriting solution.
Thank you so much, Suramitsu. We actually really have questions from the judges. Benoit, why don't you kick it off for us, please?
Yes, thank you very much for the presentation. So my question is about KYC and AML checks. How would your solution impact on KYC and AML checks?
Well, our solution is based on the Cambodian use case that we've implemented in 2019. And in this case, we built on the core banking competence of commercial financial institutions. So it's a two-tier system in which commercial FIs have the responsibility for undertaking KYC. And personally identifiable information is kept with the commercial financial institution. If there's any suspicious activity, then the central bank can pass along the wallet ID, the anonymous wallet ID, to the commercial FI, and can use existing legal channels to subpoena the PII, and then prosecute as needed.
In this case, it's important to specify that KYC is shared in between private actors. So the lender can get confirmation of KYC was made by the hosting institution for a specific wallet.
Yes.
Maybe we'll move on very quickly to the next question, Mr. Vasudevan, I believe you have a question.
Yeah, thank you for the presentation. I was keen to know actually where the data resides and who owns and gets access to the data.
Yes, the data resides on the core ledger, which is operated by the central bank. However, the data on the ledger is written in the form of anonymous wallet IDs. So the central bank does not have access to personally identifiable information unless they go through proper legal channels. The Boolean query data is kept by the commercial bank that made the query. However, that data is only in true-false form, so it has no relevance outside the context of the original query. Also, it's a snapshot rather than longitudinal data, so its commercial exploitability is low.
Thank you very much. We'll do one very quick one. Tobias, please.
How is the system interoperable with foreign currency CBDCs or foreign currency stablecoins?
Excellent question. That's among our next steps. In fact, the Bakwang system has currently bridged over to an agreement with Malaysia's Maybank. So transfers between Cambodian citizens living in Malaysia, migrant workers, and their families who live in Cambodia are currently possible using Bakwang. The MAS solution that we've designed currently is made for domestic use. Loans between a citizen of one country in one financial jurisdiction and a bank in another financial jurisdiction are legally problematic. So we would have to design a legal infrastructure capable of facilitating such a process before we could tailor the technical solution to match. But the technical aspect would actually not be that difficult. It would be more about assembling the stakeholders required.
I think that's all time. We have time for questions. Thank you so much, Suramitsu and judges. All right, and next up, let's invite the team from Xfirst and Seba. Over to you.
Welcome everyone, and thank you for attending this demo of the solution to the Global CBDC Challenge by SIBA Bank and Xfirst. In order to comply with the 5 minutes time limit, we have prepared a short video introducing our solution.
While digital money has been a reality for several decades, many worldwide are advocating for a new form of digital money, CBDC. A central bank digital currency, or CBDC, represents a direct claim on the central bank, hence decreasing counterparty risk and increasing financial inclusion. However, if a central bank were to issue CBDCs directly to end users, a major disintermediation of existing financial systems and a reduction in the availability of credit in the economy may occur. To address these issues, StraitsX and SIBA Bank conceptualized a hybrid CBDC, in which CBDCs get distributed by existing financial institutions and a direct claim on the central bank is established. With this model, financial institutions will continue to provide credit to the economy, while making sure that money distribution is safe and compliant. To enable financial inclusion while giving new properties to money, our architecture offers interoperability across multiple infrastructures, so payments can leverage the most suited network for each use case. This enables both account-based and token-based payment systems, permissioned and permissionless networks, as well as various use cases, be it domestic or cross-border transactions, small or large amounts, or if you prioritize speed or fees. Our CBDC solution, XSGD, is already live for the Singapore dollar on the Singapore Domestic Payment Network FAST, the Ethereum Decentralized Blockchain, and the Zilliqa Decentralized Blockchain. Since its release in October 2020, over 2 billion Singapore dollars has been transacted. With consumer protection in mind, our CBDC solution is fully collateralized by cash held with a commercial bank. We are strongly committed to compliance excellence, transparency, independence, and security. Hence, our solution strives to meet the highest regulatory standards, including KYC, AML, and CFT. Transactions are monitored using the latest technology. A function to blacklist addresses and freeze funds, if prompted to do so by law enforcement, has been introduced in the smart contracts. Finally, we've also conducted full-scale automated travel rule test transfers to ensure compliance with the latest Financial Action Task Force guidelines. At a wholesale level, transactions between financial institutions and with a central bank requires more privacy. We have designed a Layer 2 solution that leverages zero-knowledge proof for institutions to encrypt the values of wholesale CBDC transactions. We believe our proposed CBDC model offers the best of privacy, performance, interoperability, and scalability all at once. CBDC is the future of money, and our already live hybrid CBDC solution paves the way forward.
So we have demonstrated how our hybrid CBDC model promotes financial inclusion, decreased counterparty risk, and is safe and compliant. Our CBDC model uses public blockchain for transaction scalability and performance. It also leverages existing payment rails, and it makes uses of zero-knowledge proof solution to ensure confidentiality of transactions. It has been an honor to present our vision of hybrid CBDC and its benefits. Thank you very much, and we look forward to answer your questions.
Thank you, Xfirst. Thank you, Seba. Now, judges, I believe we've got 3 questions, 1 minute for each question. Professor Kenneth, maybe you want to start us off, please.
Thank you. It was a very impressive presentation, and look forward to hearing more about this. My question is, what do you view as the main benefit relative to the current system? Is it the financial inclusion? Is it cross-border payments? What is the need for the CBDC if we were just looking within Singapore? Where do you see the biggest improvement on the existing?
So on this, we're seeing it, our solution as being the best, basically, of both worlds for central banks. Central banks will remain in control of the monetary policy, and not only that, but it will optimize the monetary policy. And then all the operational tasks will be delegated to financial intermediaries, which will take care of KYC duties and distributions. So it's basically an optimization that we are really seeing. And for the end user, obviously, transaction speed, efficiency will be key here.
Thank you very much. Jean, next question, please. And contestants, just a reminder, keep your answers short.
Thank you very much. I will keep my questions short. So what you propose, is it a real CBDC or is it tokenized in money? And is it really a claim on the central bank? Thank you.
Thank you. As of today, it is the reserve with a commercial bank. And our model essentially suggests that our current live token can be further improved by establishing a direct claim on the central bank, be it a guarantee on the reserve with a commercial bank or a different model.
Vasudevan.
Yeah, thank you for the presentation. I was keen to know how scalable your system is. For example, if it were to be imported to India, will it work? So just wanted to understand the scalability issue.
Right. So on this, we are running the CBDC itself on various infrastructure, whatever it is, token-based or account-based on domestic payment network or public blockchains. And the public blockchains actually bring the interoperability where domestic payment systems are lacking. So this is essentially the improvement that we are providing to existing solutions.
We've got 20 seconds left. So Tobias, I think probably more of a comment than actually a question for the team, please.
Is the system compatible with competition of different service providers?
It is currently supported by various platforms in the fintech ecosystem.
All right. Thank you very much. Thank you, experts. Thank you, Sarah. And next up, let's invite the team from Shareable Asset and Standard Chartered Bank to present. Over to you.
Thank you for listening to our pitch today. As part of my day job at Standard Chartered Bank, I help sovereigns raise bond financing. This has led me to see that government bonds, despite being the safest asset any citizen can invest in, was in fact inaccessible by many, mostly due to high minimum denomination and the need for multiple intermediaries. This is why I formed Liberty, an entrepreneur venture funded by SC Ventures. Together with our partners, Shareable Asset, we present our slightly left field solution today. Rather than focus on how CBDC should be created, we focus on why everyday citizens should adopt it. By providing easy access to ultra-low denomination retail government bonds denominated in CBDC and allowing peer-to-peer transfers of that, we seek to solve the issue of adoption so that when we build it, they will come without expensive and time-consuming enticement programs. In our demo, we will show that our system is truly interoperable with all models of CBDC. Over to you, Keith, to take us through the demo.
Thank you, Aaron. Moving now to the demo stage of our solution, I would like to play a video in the background while explaining in more detail what it is showing. First, I want to point out that there are two user groups we cater to in this solution. First is the government that will raise funds from a wide investor base and issue CBDC-denominated bonds. And the second are the retail users or citizens who will be purchasing these bonds with CBDC and earn additional CBDC as interest at a higher level than they could receive from a fixed bank deposit. As you view the demo, I also want to highlight that there are three environments that we are showing. First is the Cbdc layer, which in this demo is utilizing the sandbox of Partior, although we've also done the same integration using the MasterCard sandbox as well. The second is the back end of the application, which will manage the bond issues themselves, user accounts, as well as the transfer of funds from the Cbdc layer to the app layer. And finally is the mobile application, which is the interface that the retail citizens will use to purchase and trade the government bonds. So the first process we showed in the demo was the creation of a government CBDC bond from South Africa in this case. What it showed was that the bond issuer, the government, can sign into the app web portal and create a new CBDC denominated bond issue. Following the completion of that, which is of course protected with certain authentication and approval requirements, the bond will show up in the mobile application of all retail users as available for investment. The second process we showed, which are steps 2 to 5 in this video, is the onboarding of a new retail user, including the funding of the user's wallet. During initial registration, a new retail investor can sign up using a mobile number on the mobile app. KYC steps are also completed on the app, and depending on the jurisdiction, the process can be simplified by integrating into a national service such as SingPass that we have here in Singapore. Following the successful onboarding, retail users must fund their wallets. This is the key stage for our solution, since it is when the users who want access to the higher interest rates of a government bond will be incentivized to open a CBDC account for themselves if they do not already have them. With that, the funding of the wallet involves 2 steps. The first is to request the CBDC tokens in the mobile app, and the second is to transfer the CBDC from the user's wallet to a custody wallet of the Cbdc Layer. When that is complete, the user will have CBDC representation in their app wallet, which in our solution resides on the Stellar public blockchain. The third process, which are steps 6 to 8 in this video, is the subscription and allocation of the bond itself. This involves both the retail users and the government issuer taking part. After the bond has been created and displayed on users' mobile apps, they can proceed to subscribe in as small a denomination as the government is willing to offer. The advantage of our solution is it allows for efficient handling of small denominations, which in turn maximizes the incentive for more users to start using CBDC that may not otherwise have previously registered for CBDC accounts. During this process, the bond will be allocated and security tokens will be sent to users' wallets in exchange for the CBDC, and the CBDC will transfer from the custody CBDC account to the government's account in the Cbdc Layer. In the fourth process, we showed the payment of coupons. This is, of course, the key reason why retail users would want to own government bonds in the first place, where we're keeping their funds as a bank deposit, and it is the true carrot that is being offered to drive CBDC adoption. And finally, we showed the ability of users to trade these government bonds between themselves, as well as withdraw CBDC from the app to their CBDC accounts in the Cbdc Layer. This is important to provide liquidity to users, as the length of time someone will want to keep funds tied up in government bonds versus a CBDC ready to be used for payment will vary by the individual. Thank you very much for your time.
And thank you, Shareable Asset and Standard Chartered. Judges, it's time for your questions. I believe Professor Kenneth, you've got the first one. Professor
Thank
Kenneth,
you. I'm curious how you view the problem of disintermediation of the banks. Why would anyone hold bank account anymore if the CBDC is paying interest and is so convenient? And how would you deal with that?
And it's an excellent question, Sam, and it's actually one of the key themes around the progress that we're making, and certainly I think while this disintermediation of the banking stream, and obviously as someone in a bank, it can be problematic. I think it's just a natural evolution of things to come, in the sense that if things become much easier and much more consumer or retail focused, then banks will reinvent themselves and basically evolve around that, and not have to deal with the similar impact that they've had, or the hegemony that they have had over the course of the last century or so. So I think that evolution is something that we can look upon, but yes, you're absolutely right. If this happens this way, there will be some amount of disintermediation. Now, obviously, it's not an overnight process as well, because it's going to take time for government bonds to build out in natural token form. But starting out, especially to the unbanked or focused around the low denomination, to bring in a broader audience is where we want to target, and therefore will not directly impact banks at the onset. But eventually, if this grows properly, it will. Hope that answers your question. Thank you.
Very quickly to the next question, Tobias, please.
Yeah, are these treasuries liabilities of the finance ministry or the central bank? How are the yields determined? Do you auction off a given quantity and the yield is endogenous, or do you fix the yield in the supply, whatever there is?
Absolutely, an excellent question. Thank you. First of all, the model in terms of the issuer can be either. Obviously, different countries have different models of issuance, either from the central bank and or from the fiscal side of the Ministry of Finance. Either is obviously possible. In terms of fixing the yield, the great thing about this is the fact that, first of all, most countries have an active government bond yield curve, of which we can easily determine what the yield should be. and the yield in the coupon will be fixed in the beginning. And in fact, the trading or the exchange will be allowed in a very narrow band, such that it's not something that you can speculate on, but would follow the government yield curve.
10 seconds left. One last one, Vasudevan.
Yeah, I just want to know, this works very well when everybody is online and everybody is on the network. What happens if somebody wants to do the same activity offline when no connections are there?
Unfortunately, time is up. If we're not able to accommodate that, I do apologize. But thank you very much.
Happy to get back to you if we can.
Thank you again, once again. All right, next, let's invite the team from Citibank, and over to you.
What is a promise? There is none stronger than the sovereign's promise. Coming soon in digital form, but the sovereign's promise is not alone. There are many allies. The regulated liability network is the network of digital promises.
Welcome to a vision of retail CBDC delivered through the regulated liability network. While each institution is different, we make and keep our promises to pay the customer on demand at par value in national currency. We use different ledgers today, but creating our own instruments only leads to fragmentation. In the future, we use a shared distributed ledger. This unique multi-tier scalable model complements existing banking systems, fraud and KYC processes. New players and other central banks can easily join the RLN.
The regulated liability network is a shared space for different promises. Central bank money, commercial bank money, e-money. Each regulated institution places its promises in a single network of value. Always on, programmable, powerful.
The solution is implemented on the Settle blockchain. Each partition, including the central bank, is an issuer of tokens on the Settle ledger. Issuers have control over token movements. A transaction is proposed to the RLN as a collection of changes in partitions as a Settle smart contract.
Our first use case illustrates how the RLN can be used to make a CBDC payment directly from the government to a citizen, and then how the citizen can make an onward payment using a local payment scheme. As part of a pension arrangement, MAS makes a payment of $1,500 to Mary using her national ID. Mary has a wallet with OCBC Bank. CBDC tokens are directed to OCBC, which in turn issues OCBC tokens to Mary. This is done as a single transaction on the RLN. When Mary receives tokens from OCBC, she decides that she wants to make a payment to her son, who uses PayNow. To do this, Mary swaps 100 of her tokens for a balance in her checking account. From there, she makes a payment in the traditional way using PayNow. RLN works seamlessly between MAS, OCBC, and Mary. It converts real time into a traditional retail account and interoperates easily with the local instant payment system.
In a second use case, Mary sees a scarf she likes on eMarket, an online marketplace. eMarket has an RLN wallet with Citi. On the checkout page, eMarket presents a QR code, which Mary scans using her OCBC wallet. Mary authorizes the payment in her RLN wallet, and a single instruction is sent to the RLN. That instruction breaks down into 3 actions on the RLN. 50 of Mary's OCBC tokens are cancelled from Mary's wallet. 50 Singapore dollar tokens are issued by Citi to eMarket, representing a new promise from Citi to its customer. CBDC tokens are moved from OCBC's wallet to Citi's wallet at MAS to settle the transfer simultaneously and in real time. When eMarket receives its token from Citi, it can make a payment to Ryan, the seller of the scarf, who has an RLN wallet with Payoneer. Ryan can then log into Payoneer to check that he has received the funds.
MAS can also choose to issue retail CBDC directly to Mary rather than via OCBC. Mary wants to invest money into bond blocks, investment tokens issued and traded on the Bondivalue blockchain. First, she needs to fund her account at Bondivalue. From there, she issues an RLN request to pay. This will now help transfer value from her MAS wallet to Bondivalue's wallet at Citi. Mary authorizes the transfer, and RLN orchestrates token movements at MAS and Citi in a single atomic network update. Bondivalue is notified of the RLN transaction, credits Mary on their Hyperledger Sawtooth blockchain allowing her to complete her purchase of bond blocks. Bondivalue bridges RLN and Hyperledger Sawtooth by having a presence on both networks, creating interoperability. These were our 3 use cases of the many more.
The regulated liability network is a vision of a less siloed financial infrastructure where the money is in the network and not at the edges. The sovereign's promise is joined by our own. We build the next generation of financial infrastructure right here in Singapore. If you want to go fast, go alone. If you want to go far, let's go together.
And thank you very much, Citibank and OCBC. Judges, actually, Benoit, why don't you just kick us off right now?
Thank you very much for the presentation. I have a simple question, which is how would you describe the added value of your solution compared to a traditional RTGS system, let's say a fast RTGS system where commercial banks can also participate and which provide additional functionalities such as netting?
I can kick off and then my partner Anthony can chime in. I think the biggest power of the RLN, because it's a shared DLT network where every institution has their own partition, including potentially the central bank, and which represent their liability, I think, and at the same time, it leverages DLT technology, which is programmable, always on, and can be multi-asset class. This actually brings in a few unique advantages that traditional systems don't. Our traditional financial market systems can be fairly siloed, where there is infrastructure built, which is purpose-built for a specific instrument. Whereas in the RLN, you could actually have multiple central banks who could have different partitions. We've received a lot of interest from central bank. One European central bank has already agreed to do that. And you could imagine that this then creates a global RTGS system, which addresses a lot of issues which current systems have today. You could also have multiple asset classes on this DLT. We showed you a fractionalized bond use case, but we've also tested a use case with one of our 12 institutional partners for the issuance of bonds and atomic one-to-one RVP, DVP settlement and placements of bonds. So the multi-asset class nature, the multiple central banks potentially joining the RLN as an additional point really makes it far more unique, while at the same time retaining the advantages that the traditional systems have.
Right. Very quickly, Dr. Patrick, next question, please.
Thank you. Question is about financial inclusion. So this system, how do you actually expand to the excluded in the current system?
So that's a great question, Doctor. And I think the fact that the RLN actually retains the pure nature of the retail CBDC as well. So for example, we demonstrated the MAS partition in which the central bank would have direct liabilities to individuals without having any other institution in the middle. Then this actually becomes very complementary to all of the other use cases that we'll be presenting today. So it's completely up to the central bank on where they, it's like sovereign embassy is a sovereign territory in a foreign country. So in that sense, the MAS partition is their own partition. And they could choose to actually issue different levels of KYC. So they could choose to issue a retail CBDC purely by looking at national identity where there exists. They could choose to use different solutions of offline transfers, which are permitted with lesser levels of KYC if they so wish as well, to include.
Sorry, that's all the time we have left for questions. Do apologize, but thank you very much. And now let's invite the team from HSBC to present. Over to you.
Thank you. Good evening, everyone. We are from HSBC. Please see our videos for details of our solutions.
Our solution analyzes 12 problem statements in this global CBDC challenge and includes 15 dimensions. Based on our analysis and research, we summarize that consensus algorithms and related operating models are key components of CBDC design for central banks. Consensus algorithms and distributed ledger technology play a significant role in retail CBD systems. They have direct impacts on many properties of a retail CBDC system, including performance and privacy. It is therefore essential to properly evaluate consensus algorithms and do the related calibration. Besides, most retail CBDC pilots have shown a tiered structure as operating architecture, in which privileged institutions distribute and circulate CBDCs for non-privileged institutions. The privileged institutions take the role of financial intermediaries and payment service providers. However, non-privileged institutions and the mass public have concerns of data monopoly, and especially for non-privileged institutions, they are reluctant to provide their customer data to privileged institutions. Note that there are no mature technical solutions to keep business secrecy for now. So, operating models are leveraged to handle the data privacy and business secrecy issues. Therefore, we built a recommendation platform to provide central banks with consensus algorithm recommendations and operating model options. Here's our recommendation platform. There are a lot of differences between different jurisdictions in terms of national conditions and the focus of regulators. By inputting national economic and regulatory conditions, we can see focus of a retail CBDC on the right side. By analyzing diverse DLT consensus algorithms, we built a theoretical framework that splits consensus algorithms into different components, such that impacts of each component on the above-mentioned retail CBDC dimensions can be derived. Based on this framework, we further recommend consensus algorithms suitable for national economic and regulatory conditions. And users could further fine-tune consensus algorithms if needed. Additionally, we provide operating models to improve business secrecy, which could not solely be implemented from the technical side. In most retail CBDC implementations around the world, a tiered model is selected, where privileged institutions are at the higher tier, while non-privileged institutions are at the lower tier. Besides, transactions among participants of privileged and non-privileged institutions would be regarded as valid only when they were recorded in the ledgers of a higher tiered institution. However, in the tiered model, because privileged and non-privileged institutions are competitors, their data should not be shared to keep business secrecy indispensable for non-privileged institutions. Therefore, we provide two operating models as options to solve this problem. 1. Decentralized identifiers, or virtual addresses, on the account level to support current technical solution in CBDC tiered structure. And use dynamic virtual addresses to avoid higher tiered institutions knowing identities of participants. 2. Set up an independent operating organization without interest conflicts of other participants. After finalizing consensus algorithms, platform users can use the platform to generate a sandbox environment to test recommended consensus algorithms. After network deployment, we leverage AWS EC2 computing resources to carry out performance tests. We divide payments into two types. One is human-to-human payment, the other is human-to-machine payment. We can see a theoretically infinitely large TPS based on our experiment results. In summary, our solution shows how to achieve high performance while maintaining data privacy and business secrecy. Depending on different national, economic, and regulatory conditions, the evaluation platform can provide various consensus algorithms to address retail CBDC needs of most countries. In parallel, the operating model can help non-privileged institutions retain their business secrecy.
So we are still in an early phase, and we'll further develop and integrate more components of diverse consensus algorithm. When our platform reach certain degree of maturity, it is planned to make the whole platform and the related
time is up, unfortunately. Maybe you can address that in the Q&A very quickly. Jean, why don't you kick things off, please?
Thank you. Thank you very much for the pitch. One question. Don't you think that your virtual addresses are going to make money laundering investigation more complicated?
Yes. So this is a kind of design, right? So we can make sure that we keep, say, for certain amount money, with certain amount money, we use what kind of mechanism, including the virtual address. On the other hand, even for the virtual address, for the central banks or for the regulator, we can still provide the mapping table, such that the regulator have all the data while the commercial banks or institution, they do not have the business secrecy of other party.
Benoit, next question is up to you.
Yes, thank you. Very interesting proposition. I would like to know how scalable it is to DLT platforms other than Corda for which it's built.
Oh, okay. Actually, our experiment is more or less use the Corda, the open source Corda as a basis to build a related solution, and also we do not, for example, for other DLT technology like Hyperledger, we can imagine the performance will not have a big difference because the main impact factor is related to the DLT consensus algorithm, and we are fine tuning the consensus algorithm. For this part, we try to make sure that they have the high performance.
Sri Vasudevan.
Yeah, thank you. I was very curious to know how will you handle offline CBDC transactions? What are the infra requirements that you need?
So yes, thank you for your question. Right. So from the offline side, so for the consensus algorithm, currently our main focus is mainly on the online things. But for offline, yes, I think it's also related to part of the consensus algorithm. I think maybe in our current phase it's not covered, but as I mentioned, we will consider this point and further fine tune the consensus algorithm for that.
Thank you very much, and I think that's all the time we have for. Thank you, HSBC and judges.
Yeah, thank you.
All right, and next up, let's invite the team from Academia and Consensus. Guys, over to you.
Thank you, Gabriel. 1.7 billion. 1.7 billion people still do not have access to a bank account. Financial inclusion is a top priority for central banks throughout the world. To implement a central bank digital currency, smartphones just cannot be a one-size-fits-all solution. Two reasons to that: poverty and tech illiteracy. At Academia, we believe everyone should have access to financial services. That's why we brought together Consensus's blockchain with Academia's wallet solutions. For everyone to have access to CBDC, the solution should work with any device, be it a smartphone, of course, but also more affordable devices, such as a feature phone, a card, biometric card, wearables, and even connected machines. Besides, it should not require the user to have a bank account. Doing so, it would work for everyone easily with no friction. But it should also work all the time. The BIS always highlights offline capability as a key feature. CBDC must work anywhere, anytime. It must work even in network dead zones when a natural disaster hits or in case of a massive cyber attack. Moreover, because CBDC will be legal tender, it must be acceptable anytime. This solution exists, and let me show you how it works. Here is Michelle. She is not comfortable with technology. A bank clerk issues her a biometric smart card. She runs the KYC check, as our system is account-based, as recommended by the BIS. Then Michelle enrolls her fingerprints to the card and charges cash. She's good to go. She can then buy her lunch from Lee by just tapping her card on his smartphone. Because both Michelle and Lee's devices use a secure chip, they can spend offline. This is exactly what Lee does when he pays for his coffee at the cafe. Since the cafe's equipment does not have a secure chip, it will need to go online with the blockchain to pay for its utility bill. If we look at the blockchain, we can see the transaction posted on the ledger. Our solution works anywhere, anytime, and for everyone. Offline payment also allows us to address another important issue, resilience, by relieving the online network and minimizing risks of failure. But Lorraine, tell us, is it secure?
Yes, we only use tamper-resistant certified hardware chips, and we don't use trusted execution environment as they are not considered secure enough for offline payments.
What about citizens' number one concern, privacy?
So those secure chips, they can enforce the rules set by the central banks on their own. They could apply a privacy profile, for example, by hiding the identity of the spender, as long as the amount spent does not exceed a certain limit. And the type of biometry we use allows self-sovereign identity.
Impressive. But does the entire existing infrastructure needs to be replaced?
No. We could use the same terminals, same standards that we use for payment cards. Our solution works on any channel, contactless, email, QR codes, even on paper. QR code can act as a voucher which you can spend on a predefined set of merchants. That is an example of programmable money.
Thank you, Lorraine.
Thank you.
And thanks to our team. As you should know, 5 different R&D centers on 3 continents collaborated on this project. Building upon our existing offline payment solution already used in proofs of concept with European central banks, we've addressed 11 of the 12 problem statements set by the challenge organizers. Martin Luther King once said, "There is nothing new about poverty. What's new, however, is that we have the resources to get rid of it." At IDEMIA and Consensus, we believe CBDC can be one of these resources. Let's act now. Thank you, and thanks to the organizers. I will take any question you may have.
Thank you very much. And with that, Madam Darta, you have the first question, please.
Okay, thank you. Since the IDEMIA over the secure chip solution, how can a smart card with the chip technology from you can support the financial inclusion? Because I guess it's quite costly for the distribution of this card, particularly for the archipelago country. Thank you.
I can respond to this one. That's a very good point. Today, we have the solutions, we have the distribution centers to put cards, to put smart cards in the hands of users basically anywhere. We have some remote solutions, for example, with local issuance centers. You mentioned archipelagos. So we can have a central issuance distributing the data locally so that locally we can print, between quote, program the cards and hand them to the users.
Very quickly, moving on to the next question. Sri Vasudevan, please.
Yeah, thank you. I was seeing that you use extensively the chipsets. I was keen to know whether these chips adhere to any global standard, and how do you ensure that these chips are certified when the solution is rolled out to large masses?
Good. Olivier, do you want to take this one?
The chips we're using is the same one we're using for IDs, for banking. So they are government grade, tested every year. They are standards and using the standard Java global platform. These are chips that we are able to provide in cards, but also they are available and they are the same as the one in SIMs or in any wearable.
Benoit, next question for you.
Yes, thank you very much, and thank you for the presentation. It was not clear to me whether your solution would require a specialized hardware, and if so, how does it scale up?
Owen, do you want to take this one?
Okay, so we have several hardwares actually that we considered for this prototype. We are able to work on a SIM card in a mobile phone, which is a chip equipment, the SIM card, and which equips all the phones. We are able also to work on the biometric smart cards that you have seen in the video. So those are all the hardwares that we are able to provide. But not only the secure elements, we are able actually to accept a payment on any device. It's when you spend the payment that you need either to go online on the blockchain if you don't have a secure element, I mean physically secure, or if you have a physical secure element, you can spend it immediately offline. Does it
Thank you
answer
very
the
much.
question?
Yes, and that's all the time we have for questions. Thank you very much. All right, and now, next, let's invite the team from IOG Singapore to present. Over to you, please.
Hi, we are Input Output, the makers of Cardano, the top environment-friendly blockchain by market cap, and today we're going to present Unchained, our solution for retail CBDCs. A CBDC is a digital currency that is issued by and the liability of the central bank, and to be retail, it has to be widely used. To be widely used, a few key problems need to be solved, such as, for instance, the CBDC needs to be usable even among people who lack financial inclusion or basic infrastructure. It has to be available even if you crash on a kangaroo in the middle of the Australian outback and you have no mobile signal. It has to be resilient in case you're living in a place that is susceptible to occasional blackouts, even if it's in a country like Brazil, where a system like PIX, one of the most advanced fast payment systems exists. And the CBDC should also be attractive to people who, for various reasons, would prefer a cash-like experience. In our solution, Alice would like to send some money to Bob, but they lack internet access. But they do have, for example, Wi-Fi or Bluetooth, and they would like to use that to perform an offline transfer. What Alice does is to create what we call a CBDC check, and she signs that with her cryptographic key and sends that over to Bob with zero cost and no scalability bottlenecks. When Bob is online, he can redeem this check against the CBDC backend infrastructure. We chose this approach because the notion of check is something that people are used to. So this makes our solution more accessible and with lower friction for people with low technological literacy. Also, the risk of dispute in the case of physical checks is already well known, and it has already been accepted by society before. So we believe that this would be an acceptable risk for digital CBDC checks as well. Let's see a demo of our solution.
Hi everyone, my name is Dragan. In front of you, you can see two separate windows, Alice and Bob, which are real devices but mirrored on screen so it's easier for you to follow along. The Unchained wallet has a main account and check funds account. Check funds account holds funds for backing checks. First step Alice needs to do is to deposit some amount from the main account to the check funds account. For example, we'll deposit 100 digital Singaporean dollars. After the deposit is completed successfully, Alice is then able to create and transfer check in completely peer-to-peer fashion, even if there is no internet connection. To demonstrate this, we're now going to switch off internet connection and proceed to creating a check. For example, we're going to create a check which holds $50. After the check has been successfully created, we can now initiate the transfer. When Bob receives the check, he can inspect its details, verify that the check has backing. He can also choose to send the check further on or to redeem it. For this presentation, we'll choose the redeem option. After he successfully redeems the check, his main account increases from initial $200 to $250, the same amount the check was holding. That would be all. Thanks.
Our solution is agnostic to the back-end infrastructure of the CBDC. So it could be a centralized server operated entirely by the central bank, or it could be a two-tiered architecture to avoid disintermediation, in which case our wallets would be interfacing with the commercial banks instead. The backend could be based on a private permission distributed ledger run by the central bank and other financial institutions. Or it could even be a public permissionless, fully decentralized blockchain. And for the demo that you have just seen, we have interfaced our wallet with a public permissionless blockchain. And here you can see the smart contracts that we have used on the public permissionless blockchain. You can see here the function that handles check redemption. So in summary, by relying on major technology with high penetration.
Unfortunately, very sorry, time is up. We'll move on right now very quickly into the questions. I think Professor Kenneth, you have a question for the team. Please go ahead.
Yeah, thank you. This is a very exciting technology. I'm trying to understand, is this a app to go on top of a CBDC mainly, that you could use it with anyone who's, you speak about the back end of the CBDC, but that's like a lot of the what we're worried about here. And you're a generalized application to use with CBDCs or replace them. I was having a little trouble grasping that. I apologize.
Yes, we have built it as a wallet that can interface with other CBDC infrastructures. Now, we could eventually have the CBDC itself being a token that is held by the wallet in the same way that the CBDC checks are held by the wallet right now. Right? We are working on additional features to make that happen.
Thank you very much. John, I believe you have a question for the team as well.
Thank you very much. Thanks to the team. A very simple question. You use the image of a check. Are you making it equivalent to an end user check or to a certified check, like a bank issued one on behalf of a customer?
The check is issued by the user. Yeah.
Right. Thank you very much. Sri Vasudevan, take the last question, please.
Yeah, thank you. But if you are planning to have a device-held distribution approach, how are you planning for the SDK distribution and protect the ecosystem of non-trivial access to the SDK?
What we envision is that users would install this wallet in their mobile devices, so there is no need for the user to interact with an SDK. Now, if you're talking about developers interoperating with our wallet, so we are using only standard technology. So for cryptographic keys, we use a standard technology. For smart contracts, we use Solidity. So yeah, we have this effort, to always use standard technology that is available. So that if you decide to use our wallet for your CBDC, our wallet will not be the only wallet that could interact with your CBDC. Like these checks, they could be moved to wallets made by other companies that follow the same standards.
All right, thank you very much. And that's all the time we have. IOG Singapore, thank you very much. And now let's invite the contestants from GND to present. Over to you.
In the next 4.5 minutes, I will show you how our GND CBDC solution delivers true benefit to our society in 3 domains. As a great means of payment that can universally be used, that is truly inclusive, and that can foster innovation and growth. Driven by how a well-designed CBDC can benefit society, we developed GNDphilia as our solution. Since day one of our development, we envisioned beyond the existing to enable secure offline payments. However, it is not only capable of a single offline transaction, but secure consecutive offline payments, even without mobile network connection. Obviously, there's a broad consensus that smartphones will continue to dominate mobile payments. GND's range of options in online and offline payment scenarios will dramatically extend accessibility, empowering the unbanked and underprivileged to participate safely and easily in the digital economy, which is not possible today. At its core, GNDphilia is a token-based approach with privacy by design and offline functionality as key features. To enable this, we developed the Filia protocol to allow a seamless and highly secure transition of tokens between the online and the offline world. Here you can see it in use. The Filia ecosystem is utilized by central banks worldwide, trusting GND's unique experience both in public money as well as private payment schemes. One partnership we can publicly discuss is with the Central Bank of Ghana. Currently, only about 84% of Ghanaians have stable access to electricity, while just 53% were connected to the internet. Imagine the impact a digital cedi will have on their citizens and economy. So, what makes a great means of payment? It must be accessible, even without a bank account, easy to use, low cost, private, and it must have integrity. Our solution consists of 3 layers. The Ultralight payment layer tracks integrity, but not ownership of the monetary tokens circulating in the system. Payment is simply done by transferring such a token from one device to another device, utilizing various communication channels. We can guarantee authenticity of payments without storing personal data nor transaction metadata at that level. Next, we have the data layer that only stores pseudonymous transactions required to assure anti-money laundering and countering the financing of terrorism. On the data layer, it can be defined which data is stored and who can access it according to data contracts. This enables us to truly balance privacy versus transparency in a way that is audible by third parties. Our smart wallet infrastructure, the third layer, provides a powerful rule engine that enables interoperability and innovation, like, for instance, machine-to-machine payments based on smart contracts. The Filia Cbdc ecosystem consists of multiple components tailored towards the needs of all stakeholders. Our software development kits enable private sector players to develop programmability use cases, which will certainly enhance competition and drive innovation. It's a pivotal time for the future of money, an opportune moment to create a truly inclusive public digital currency, one that can even solve the simplest of all payment scenarios. 2 people in the middle of nowhere without connectivity, but still able to make a payment that is digital, of course. Thank you very much, and we look forward to any questions. And I'm happy to bring now Raul, my colleague, to the stage. Thank you.
All right. Thank you very much, G&D. Judges, I think Ibu Rendata, you can take the first one, please.
Okay, so the name of the Cbdc is similar to my name. So as the solution can be used for the offline payment, how it can be ensured that the transaction can be validated when the user get back online in order to prevent the double spending?
Thank you very much. Happy to answer this question. We store for each and every transaction connected to this tokens that is transferred from one device to another device, the history. And this way we enable consecutive offline payments. 5 people can do offline transactions one by one. And the moment you get online, it will be reconciled with the online world. That's the way how we provide this feature.
Right. Thank you very much. Tobias, I believe you have a question as well.
So can you use this abroad, even if the other country doesn't have the same technology?
Well, there are various approaches regarding this. One topic, if you would be a citizen of Singapore, for example, of course, you could still utilize it in another country. If you talk about exchange between different countries, one approach would be that those different countries would agree on one standard, which might take some time. But until these standards exist, there might be digital currency exchanges, just what you find in the cryptocurrency domain as of today, and you would have market makers that could provide this as a service until there's a common standard in place.
Thank you very much. Jean, over to you.
Thank you for the pitch. Chip technology question. Once a central bank has chosen to work with you, are they locked in working with you?
No, of course not. We provide very open frameworks, open APIs, SDKs that enable other parties to interoperate. We also offer public-private partnerships as one possibility to collaborate. So in general, we are very, very open regarding this. We are collaborating with central banks since more than 160 years and are flexible to adjust to their kind of requirements in this domain.
All right, very last question, Sri Vasudevan. Very quick.
Yeah, thank you. I just want to know, how are you planning to scale up the situation, the solution in case of higher demands?
As of today, we don't foresee any challenges regarding scalability. We have one central bank we can unfortunately not name as of today, but they already did performance tests by themselves. And so far, it seems like we can really achieve the performance that is required for live CBDC in a real environment.
Thank you very much. Thank you, GND. Thank you, judges. Next, let's invite the team from Criteo, Secretarium, Intel to present. Over to you.
In 2017, we assembled a team of mathematicians, cryptographers, and engineers from Secretarium and later Criteo. We also brought in an advisory board of economists to design our CBDC platform.
I founded the blockchain lab at SocGen in 2014. We experimented with DLT technology during several years and found they could not handle the privacy requirements demanded by our end customers. In 2016, we started experimenting with a new chip capability from Intel called SGX. And then we knew it was a game changer.
Our goal was to develop a next generation DLT by writing directly to metal in the hardware instruction set of Intel SGX enabled chips. With Intel SGX, we envisioned a whole new type of system. By using secure enclaves, we constructed a safely encrypted ledger. We also improved the consensus mechanism. We created a new, high-performance Layer 1 consensus method. We call this design a Secure Enclave DLT, or SDLT, where all transactions run on-chain, greatly accelerating performance in memory. This SDLT protects all CBDC functions and data in secure enclaves. This means our entire digital currency platform is safeguarded with additional hardware-based security on top of the consensus mechanism, making it the most secure DLT ever designed. Our technology can process hundreds of thousands of transactions per second, making it faster, easier, and cheaper to deploy and maintain than other platforms.
We have over 2 billion active monthly shoppers, and every single year we see over 900 billion in e-commerce transactions across our entire network. We see our ability to handle AI-powered transactions at scale as very similar to the CBDC problem.
For its unparalleled performance and security, our architecture won Best DLT of the Year and Best FinTech App in 2020. Users are greeted with a simple dashboard for quick access to the most important features. Sending money is simple, and it works both offline and online. Just insert the details, then the system generates a QR code for the recipient to scan and receive their funds. With our dual account and token-based ledger, you can access every kind of financial holder, from commercial bank accounts to your digital CBDC wallet. Our platform can support multiple forms of money simultaneously, including account-based, token-based, and fully anonymous Xiaomi and Cash. This architecture provides a range of money options that supports anonymity and full privacy when you need it, but also full traceability for AML, CTF, and fraud detection. Whether paying for goods or splitting a bill with friends, the experience is seamless. Our architecture leverages a hybrid approach to banking, including multiple tiers of the banking system and integrations to RTGS systems. We also provide a comprehensive central bank dashboard with valuable monetary policy metrics such as average transaction size, number of new banked versus unbanked users, and with real-time metrics tailored to the needs of specific countries, central banks can adjust their CBDC rollout to meet financial inclusion and mass digitization goals. Our system supports atomic swaps, which are key to interoperability. We believe this is a breakthrough for multi-currency CBDCs, with the BIS's proposed Model 2 and 3 implementations, supporting both instant and near zero cost cross-border payments and remittances. We envision completely new forms of money in the future. We call this the periodic table of money. where money has atomic properties like gold in the 19th century.
Our system architecture, particularly the programmable features of the periodic table of money, can potentially transform the way central banks conduct both monetary and fiscal policy. For example, by dialing the interest rate coefficient up or down, the central bank can directly affect the behavior of consumers and businesses, rather than relying, as they do today, on the attenuated transmission belt of first making a policy rate decision, then engaging in open market operations through securities dealers, which then affects financial institutions' interest rates, which finally, at some point, affects the behavior of consumers and businesses. Using our system, the transmission is direct and immediate.
We believe our next generation platform offers a transformational breakthrough in scalability, security, and application extensibility, putting it in a new class all by itself. Our CBDC platform has been in development for more than 3 years. Today, we are in discussions with central banks in Latin America, Africa, and Central Europe, with current pilot programs underway. We're ready for Singapore, and we thank you for this opportunity.
Thank you very much, team. Dr. Patrick, I'll let you take the first question, please.
Thank you. Thank you very much for the presentation. Question. You have a platform very secure and providing anonymity on the lower end of the transactions. Is that really the most, let's say, problematic issue for consumers? So what is the value add in this regard?
That's a great question. I think it's a very important question as well, because consumers expect some kind of anonymity at the low end, or they may be dissuaded from switching to cash to digital currencies. So our system allows for anonymity, complete anonymity at the low end, but where regulations and law occur, the system through an atomic swap will automatically switch to a different type of a token or to an account-based structure so that you can affect AML, counter-terrorist financing, and other transparencies. There are also other types of tokens that can be used to affect a provable transaction, where, for example, if I'm paying for my taxes, I want to be able to prove I paid my taxes, and the government wants to be able to prove that they received the cash from a particular resident or business. So that's a very, very important piece of our architecture.
Thank you very much. Professor Kenneth, next question, please, to you.
This was really impressive, maybe the most impressive one I've seen, I will say, so far. And but I had a couple questions. Absolutely, I was curious about what the governor of the Central Bank of Kenya asked about how you make the small transactions anonymous, but not the large ones. That's just the big question in trying to have digital currencies. How do you prevent someone from, having 1,000 mules, which we do with drug money now? How do you prevent that? And maybe I'll just leave it at that.
Yes, it's very important. We use, at the low end, we use an anonymous style of transaction called a blind signature, developed by a mathematician called David Cham. It allows the central bank to validate a transaction, but it doesn't know who the parties are. But the same token, you can say, I will allow a certain amount of transactions as a nation or a central bank up to a certain level, and then beyond that, it switches to this other type of token or account base. So handling multiple forms of cash is just critical in a CBDC platform. Right. Jim, I don't know if you have anything to add to that.
No, I think that's pretty straightforward.
Yep.
Thank you, gentlemen. Thank you, team, and thank you, judges. And now, next, let's invite the team from IBM who will be presenting. Over to you, gentlemen.
Thank you. Greetings. Naren?
Yeah.
Greetings, gentlemen. We are delighted to be here. I am Saket Sinha. I lead blockchain globally for IBM, and I will be assisted by my colleague, Naren Krishnan. We have an exciting solution for you today. What we have focused on is in the area of extensibility and resiliency. And we certainly believe that this is one of the most important criteria to make any retail CBDC solution successfully deployed in production, taking into consideration the ability for that solution to seamlessly integrate with existing payment networks or support any kind of economic activities, all facets of economic activities, including cross-border trade and everything. At the same time, we are focusing on resiliency to make sure that the solution can be governed, controlled, and monitored and secured from the nuances of the online digital world that we all know of. So we started with a point of view, and we got this point of view shaped from your problem statements, the other problem statements. And what we are solving here is that we have come up with a framework to help any retail CBDC solutions get deployed in production with the characteristic feature set that your problem statements have encompassed. So we have focused on the token aspect to manage the tokens in a privacy preserving manner. We have focused on the cache-like ease of use, the hack-proof and fail-proof ability of this retail CBDC solution to be deployed, full recoverability against loss, misplace, and tech failures, and required regulatory and audit capabilities, as well as seamless usage. So we have, in this hackathon, we have developed this Extenium open source framework that will support extensibility and resiliency with 4 key capabilities: the token management, the identity for self-sovereign identity, interoperability to help the solution interact with multiple other networks and payment rails, and a security to help it maintain a hack-proof and fail-proof solution. And my colleague Naren will demonstrate the proof points where how a central CBDC can be issued, seamlessly be used against various kind of retail buying experience with the privacy preserving solutions and a traceable manner. Over to you, Naren.
Thank you, Saket. I'm logging into the IBM site where we have hosted the multiple CBDC networks. And as Saket mentioned, IBM submission extensibility and resiliency. A lot of that happens under the cover. And we have developed the 4 core components and deployed in this production grade CBDC network. And for the demo today, we have assumed some pre-steps where the central bank would have minted the CBDC and then transferred to the commercial banks, and from then on transferred to the retail merchant and the retail consumer. And we will assume a retail consumer, Alice, who wants to buy flowers for her party from a flower merchant, Bob. Alice and Bob both have wallets in the different networks, and Alice would pay Bob using the CBDC from her wallet to Bob's wallet. I want to focus on retail network A for now. And as you see, it's built on Hyperledger Fabric. We have tested this using Hyperledger Besu and R3 Corda as well. So let me log into retail consumer Alice. So if I log into Alice, Alice authenticates herself into the network, and you would see Alice wallet showing up as 5,000 Singapore dollars. She can pay the currency to anyone with the address in the network, or she can pick one of the retail merchant, which in this case, it's in her local address book. When the transfer token happens, this is in real time, and the token is transferred from Alice wallet to Bob wallet in real time in an atomic manner. Alice can also ask for additional funds from the bank using her fiat currency as a deposit. So let me log off and log back into the Bob's account, who is the merchant, and you would see the amount that Alice transferred would be waiting for him to claim, and once he claims it, his wallet would increase by equivalent amount. And Bob can request money from the bank as well, from his bank as well. And if you see the transaction, these are the transactions that Alice and Bob have exchanged. While IBM focused on the extensible resiliency, it became very clear that the privacy and auditability features are very important. They go hand in hand. So we had created a zero knowledge proof based privacy preserving tokens that ensures that only Alice and Bob can view the transactions and not any third party. Of course, the auditor or central bank person can see this as well. Okay, thank you.
Team IBM, time is up. Benoit, judges, from the judges, Benoit, please take the first question.
Yes, thank you very much for the presentation. I like very much the focus on the interoperability that you have. One question on identity management. I mean, can you elaborate a little bit more on where does identity come from, and if there is reliance on external identity rails, how does it impact the deployment of your solution?
Yeah, it's a self-sovereign identity. It can accommodate self-sovereign mechanism as well as the identity that is issued by an official government entity, is not just one but multiple. So any kind of a central ID and central mechanism of identifying a citizen, those kind of identity can be incorporated. But at the same time, we have self-sovereign identity built in, where through series of action of the individual as well as a business, the identity can be validated through a validated set of network with proof of stake.
All right. Next question, Sri Vasudevan, please.
Yeah, thank you. I was keen to know how your solution will interact with the traditional core banking and currency management solutions of central banks.
Yeah, we have focused on that a lot. There is a concept of centralized and decentralized architectural model. So the centralized one will actually interface with the general ledgers of the core banking system at the end of the day from reconciliation and settlement. But the decentralized one is where we have kept the knowledge base, what is acquired from the transaction, and that knowledge base is transferred on from risk and auditory and compliance purposes.
Thank you very much. Just checking, do the judges have any more questions?
Maybe I'll take one question if there are none else. How is the system scalable? Has it been tested, and how is it scalable actually?
It is very scalable. That's why this is a concept of the architecture. For extensibility comes from the fact that we have used both centralized and decentralized mechanism in here. So the actual data and everything is not stored in the blockchain. We only store the hash of it from a blockchain perspective to realize the benefit. And it can support multiple side chains and other kind of chains and emerging technologies that are coming in to support millions of transactions per second.
All right. Thank you very much. If we have no further questions, thank you very much, Team IBM, and thank you, judges, as we move on to the next contestants.
Thank you all for giving the opportunity. Thank you.
And now, everyone, let's invite the next team from Bit and Stella. Over to you.
Excellent. Thank you. And once again, good day. We're excited to show you a video presentation of our products, which are in use around the world today.
Meet Silpa, a Singapore resident who's planning to visit her mom in Mumbai. Silpa needs to make payments and send funds safely and conveniently. She downloads the Bit Wallet app, which is built on the Stellar blockchain, signs up to use the app by following intuitive step-by-step instructions, and completes her application form with her name, email address, and phone number. She creates a password, and on the personal information screen, she adds her country of birth, date of birth, and current address. Next, the app prompts her to submit a photo of government-issued ID and an on-the-spot selfie for validation. She selects the country of issue, type of ID, and follows the on-screen directions to add her ID number. Silpa confirms all her information is correct and agrees to the terms of service. Just like that, her application is complete and submitted. Silpa's financial institution receives and reviews her application, and in a few moments, she receives an approval notification on her phone. Personal data is stored in databases owned by financial entities. Transaction data is stored on the Stellar blockchain. Now that Silpa's wallet has been approved, she can request to transfer funds from her bank account to her digital wallet. She submits a request for 1,000 SGD. Her financial institution receives this request and transfers 1,000 SGD from her account to her digital wallet. This transaction is recorded on the Stellar blockchain and her banking records. This part of the solution shows interoperability between a digital wallet and a bank account. On her way to the airport, Silpa stops to purchase coffee and pays with her digital SGD. The merchant's digital wallet creates a QR code. Silpa uses her app to scan the code and transfer her payment of 10 digital SGD. This part of the solution shows acceptance and adoption of Cbdc by merchants. Even though Silpa's mom doesn't have a bank account, she's able to create a digital wallet with Bit. This enables Silpa to send 200 digital SGD directly to her for a dress she wants to purchase. The digital SGD automatically converts, and she receives digital INR through a third-party regulated financial entity. Silpa's wallet shows the debited amount, while her mother's wallet shows the increase in digital INR. This part of the solution illustrates how CBDCs can improve financial inclusion and shows interoperability between CBDCs. Before Silpa travels to India, she transfers funds to her MasterCard so that she can make purchases in India from merchants who don't yet accept CBDCs. When she arrives in India, Silpa uses her prepaid MasterCard to pay 50 SGD for a cab to her mom's house. This shows the capability for offline solutions and interoperability between devices accepting a CBDC and those not yet accepting a CBDC. Silpa is enjoying the ease and convenience of making payments with the Bit Wallet app during her visit to India. However, she's gone overboard with her shopping. Back in Singapore, a warning has been triggered because she was spending outside of regular jurisdiction and because the volumes were larger than her usual spending pattern. A compliance officer opens the alert email, logs into the system, and reviews the alerts. Their role is to determine whether Silpa's wallet needs to be frozen for further review. To freeze the wallet, the officer must simply click a button. If there are any fraudulent transactions, Silpa could recover the funds. Central banks have visibility on all alerts triggered at financial institutions. Central banks can use this view to monitor and supervise all financial institutions and therefore ensure that they are adequately performing their AML/CFT roles. Central banks also have the ability to analyze transaction data and generate daily, monthly, or quarterly reports. They have micro and macro visibility on key insights, such as transactions by industry or the real-time effects of monetary policy. The Stellar blockchain allows wallets to hold and transact the CBDC issued by the Monetary Authority of Singapore only after completing a KYC onboarding step. The BIT DCMS provides a customizable layer of governance, allowing Monetary Authority of Singapore to admit and manage financial service providers in the CBDC ecosystem such as commercial banks, PSVs, and MSPs. Personal data is stored separately from the Stellar transaction records, providing consumer privacy while allowing regulators to fulfill their responsibilities.
All right. And with that, just nice. Time's up. Judges, I believe, Madam Handata, you've got a question. Please go ahead.
Okay, thank you. So how to improve the financial inclusion, as you mentioned? Is it possible to conduct the offline transaction, particularly for the elderly and also the subsistence society, that we know that they don't have a phone mobile?
Thank you. So the BIT digital currency management system can be integrated with USSD payments so that you can leverage SMS-based or text message-based payments. And we currently have our offline solution in testing and patent pending process. So yes, we will have a number of different solutions for offline transaction capabilities.
Thank you very much. Professor Kenneth, over to you.
Sorry. I think Stellar has quite a bit of experience in cross-border transactions already, and I think BIT has operating with some central banks. And I guess I wanted to ask, what is your impression about the interoperability, the scalability, and what problems have you run into that you think this further advance will solve?
Just to clarify, the advance of connecting BIT's digital currency management system with the Stellar network?
No, to the combination to connecting different advances in CBDCs in general and what we can do. I guess while I have the floor a second longer in cross-border payments, there's an issue of, how you make them all that much cheaper without obeying the same KYC that legacy financial institutions have to do.
Understood. I see a lot of opportunity in connecting these networks, both network to network. So using atomic swaps, using smart contracts for atomic swaps, Why we really like working with Stellar is because you can have multiple currencies issued on the same chain, and they have a built-in exchange as well within the protocol that you can execute more smoothly from currency to currency. Not sure if Stellar, Billy, if you'd like to say anything else.
Yeah, so I'll just add that that's exactly correct. But what you can see is perhaps a trusted intermediary that operates on the Stellar blockchain that's trusted in this case by both the RBI and MAS. But the advantage or difference from how it operates now is these transactions can happen immediately. So even though there still is an intermediary, the transaction can still go by instantly.
Thank you very much. Thank you, Bit. Thank you, Stella. And thank you, judges. We will move on to the next contestant.
Thank you.
Thank you.
All right. And now, let's invite the next team from Consensus and Visa to present. Over to you, please.
Today, we present you Cbdc Go, a retail solution for digital currency, delivering seamless acceptance. Visa and Consensus have been actively collecting insights from over 27 central banks globally. Based on those insights, we prioritize 4 key problem statements for Cbdc Go: integration and interoperability with the existing system, along with security, accessibility, and trust that consumers feel familiar with as prerequisites for on-ramp to the space. What would success mean for Cbdc? Our goal is to drive early adoption and democratize Cbdc for everyone, everywhere. Make it instant, ubiquitous, and familiar. With Cbdc Go, central banks and financial intermediaries can easily manage Cbdc networks and provide instant issuance of Cbdc-linked payment credentials through a streamlined API gateway. So how will the Go experience look like? We have 3 key moments to highlight: account opening, government disbursement, and pay with Cbdc. Let's start with account opening. I open my banking app, click Opening Cbdc Account, accept TNC. Now I'm ready to fund it. Fund from a bank's current account. Now I request my Cbdc Visa debit card. With KYC checks, it gets issued instantly, and here's my 500 ESGD. Second key moment, now I claim my government payout. I certify I'm eligible. Now I see my government payout in my Cbdc account. In a single account, what's new is you can hold different pockets of Cbdc money if they're programmed differently. Third is with paying with Cbdc. I can see my credentials to pay online at checkout, or I can push the card to my XPay wallet to pay securely in store with just a tap, all through existing payment terminal, an experience that is familiar to billions around the world.
Under the hood, our solution has 3 components: a Cbdc blockchain infrastructure, a retail payment module, and a banking application SDK. From bottom to top, first is a Cbdc blockchain infrastructure that handles the complexity and makes things easy for central banks and banks by providing standard API for the key operations. Our solution enables central banks to deploy Cbdc, monitor Cbdc circulation, and enable purchase and redemption of Cbdc from banks, hence leveraging a 2-tier distribution model. Banks can also create wallets for end users, check balances, and execute payment instructions.
Plugging into the Cbdc platform, looking at the second row is the retail payment module. It provides a seamless on-ramp to Visa's global network with over 70 million merchants, enables instant card issuance, secure payment processing, and value-added services. Connected through a gateway, a banking application SDK empowers users however they like to pay, through web and mobile and physical card with Cbdc.
This video shows how easy it is for the banks to create Cbdc accounts for each customer directly on the central bank ledger. This enables end users to have a direct liability on the boot of the central bank. The bank is in charge of custodying the private keys of its users, leveraging secure and battle-tested authentication methods.
When paying with Cbdc in a store, it's really simple for a user with just a card. Under the hood, authorization message travel from merchant to acquirer to Visa, all the way to retail bank. At this point, there's an asynchrony between instant, real-time VisaNet authentication that happens in milliseconds versus pending block confirmation over Quorum network that takes around 10 seconds. In Cbdc Go, the retail payment module applies a double spend prevention mechanism before authorizing a transaction. The design incorporates both security and performance. To settle the transaction, the retail payment module converts Cbdc to bank money. Then the money is sent from retail bank to acquirer to merchants. It's worth highlighting our solution can also support cross-border pay through Visa Treasury services with over 160 currencies.
Here we see how the API receives payment instruction from VisaNet. The payment instruction includes the end user wallet, the CBDC ID, the amount, and the recipient. We know that many merchants won't have a CBDC wallet right from the start. That's why CBDC is sent to the retail bank first, which will be settled in seconds. Retail bank will in turn pay the acquirer and the merchant using the existing bank money rails through VisaNet.
Cbdc Go is designed with future use cases in mind, including programmable government benefits, streaming payroll, and worker on-demand payouts. We invite you to co-create the future with us now. We also envision several future MVPs to complement Cbdc Go. Along with our partners, we will evolve the CBDC solution to realize longer-term goals. Our vision is to make CBDC an instant, ubiquitous, and familiar choice for everyone, everywhere. Thank you very much for listening.
Thank you very much. Dr. Patrick, please take us away. First question, please.
Thank you. Very good solution, clean. But my question is, what about the excluded? How does this solution sort of address the question of those financial inclusion? Thank you.
Thank you very much for that question. This is actually one of the future designs of our Cbdc Go, because as you can see in the retail payment module solution, we have very much showcased how you can include this instant seamless on-ramp to someone with an existing banking app. Now, what does it mean for the on-bank and the inclusion of the financial inclusion aspect? So we have been looking at a lot of these methods around financial inclusion even before Cbdc has come around. So Visa has been very creatively trying to work with different fintechs to create prepaid or debit card in terms of helping for the on-bank. So I can give you some examples in LATAM. We're working with Rappi. Rappi is an urban delivery app startup, but now they have extended to banking solution to provide prepaid and debit card for the unbanked. Similarly, say in Africa, we're working with Flutterwave, Safaricom, InterSwitch, and the likes. And in India, we're working with Innovati, which is a startup on the offline solution. So there's a bunch of kind of solutions that Visa's network is working actively with fintechs, and with the help with the fintechs as well as the banks in the future. This is very much our goal to target the financial inclusion aspect.
Right. Jean, why don't you take us to the next question, please?
Sorry, very simple question. Can a merchant that is using a mobile POS and in a bank that is not a member of Visa receive a payment from a customer using a Visa card?
Yes, so the merchant can still, because our system is designed to be open loop, and we work with many other sort of, again, it comes back to the fintech backend, and we'll make sure that merchant can accept. Of course, if Visa credential is limited in certain areas, there's going to be limitation, and we're working on other solutions to extend the level of acceptance from the merchant side, but all assuming using existing point of sale terminals.
Tobias, one very quick last question. Over to you, please.
Yeah, you mentioned that the existing Visa system is used for Forex exchanges. Is the system also compatible for CBDC to CBDC or stablecoin to CBDC FX transactions?
I will answer that first, and I'll let Matthew to chip in as well. So in the first near-term solution, the solution is from CBDC to the bank money, like so that the merchants and the business end, they don't need to upgrade any significant infrastructure. In the future, that's very much the goal. And you might have seen concurrently, we're just published this report on the universal payment channels, which is very much with the mind of supporting CBDC to CBDC versus CBDC stable.
Sorry, Catherine, time is up. Thank you very much. Thank you very much for your time. Thank you, Consensus. Thank you, Visa. And thank you, judges. And now next, let's invite the team from X2 Labs to present. Over to you.
Thank you. Hello, I'm Orang Dialame, the CEO and co-founder of X2 Labs. Our team is excited to be part of the CBDC challenge. X2Pay is the result of 3 years of development by a world-class multidisciplinary team. X2Pay supports a two-tier CBDC distribution model and is a hybrid account and token-based system. The XtoPay backend features a modified version of the XRP ledger made to support permission DLT clusters. It can interface with a tier 1 CBDC system and banking and payment systems via APIs. An interledger layer enables an open loop payment system, allowing wallet holders of one bank to transact with wallets issued by another. XtoCard and mobile wallets provide universal access for consumers and merchants with or without smartphone or connectivity. Deviceless consumers can access their accounts via plastic QR codes and their biometrics verified on the merchant or agent XtoCards. A consumer paying a merchant with an XtoCard wallet has a dynamic QR code scan to establish a secure Bluetooth connection and approves the payment. The payer and the payee post these transactions when connected to the network. For offline card-to-card payments, a payee can generate a payment request by entering an amount using the navigation touch wheel or from a preset list. Both payer and payee verify a random code to ensure a secure Bluetooth connection is established. The payee approves an expiration date for the payment. The payer approves the transaction. Both parties post these transactions when connected. Online mobile wallet users can pay each other in person with a simple scan of a QR code, or remotely by sharing wallet addresses via SMS and email. XtoPay has an off-grid first transaction architecture. Private keys generated in secure enclaves sign public transactions sent to payees over Bluetooth. The payee and payer wallets post these transactions when they're connected. Secure enclaves of XtoCard block double spending of offline value they hold. These measures, along with time-limited spending authorizations, make counterfeit card attacks uneconomical. Card-to-card transactions can be chained. In addition to universal access, XtoPay's offline capabilities address network coverage and intermittent outage and load surge issues. For the user, the agent scans their photo ID. A live face recognition is performed. Once due diligence is completed, the customer trains their fingerprints on their own card or for devices access on the agent's card. They set up a backup PIN. The user's ID is signed with cryptographically verifiable credentials and loaded on the consumer's wallet. Users have control over data shared with counterparties. Compliance personnel have approval, audit, and reporting capabilities. For recovery of lost wallets, users go through a similar KYC process. Unbanked users can cash in or cash out via connected agents or merchants. We demonstrated a photo ID-based onboarding process. Users with identities on the system are issued a recovery key during onboarding, which is linked to their ID and used for recovery. A multi-factor authentication and time locks protect this KYC recovery path. We also support an anonymous mode on the system. Our objective is to enable free consumer transactions and negligible merchant transaction fees. Based on user opt-in via digital signatures, credit risk data provided to banks can generate revenues. Consumer shopper marketing data for brands and retail channel partners can also lead to additional monetization. We're working on a system on a chip which integrates all functions needed using ultra-low power ASIC methods, lowering power by 10x and cost by 2x. Our hackathon technology stack is based on proven modules and subsystems that are deployed in the market and address problem statements 1 through 6. We have also completed design and API interfaces for integration with Alluvial's open banking platform and Mojoloop switch for banking and payment system integration, as well as R3's Corda Tier 1 system. XtoPay is near pilot ready. We're planning to launch it as an e-money solution in India and Kenya with local partners in 2022. Thank you.
Time's up. Just nice. Benoit, can you please take the first question from the judges, please?
Yes, thank you very much for the presentation. I like the architecture very much, but it relies on this wallet, right? This hardware wallet. And so have you thought about how to deploy it and how to kind of to overcome the network effects that can hamper the deployment?
Yes. So if you noticed, we do have mobile wallets. We also do have this can be a means for merchants. So it can be a merchant terminal, therefore allowing consumers to access it without to be deviceless. So we're looking to use those paths and then seed the market for actual card adoption. Also from the FMCG partners and retail channel partners, we're seeing a lot of interest to potentially subsidize the cards.
Thank you very much.
Thank you.
John, next question for you, please.
Thanks a lot. Thank you for the presentation. The way I understood the proposal, you reduce the cost by monetizing transaction data. So did I get it right? And if the customer or the jurisdiction does not accept that, what's the cost? What's the real cost?
So the actual cost reduction is due to elimination of fraud, which is typically about 0.5% to 1% of leakage on these systems. This edge security and multi-factor authentication, we think will reduce the account takeover attacks. And we think the 0.5 penny per transaction is sustainable even without the other additional monetization revenues.
Madam Handata, next question. Over to you, please.
Okay, it is mentioned that the offline transaction can be changed and also card to card before they are finally posted. So what is the settlement mechanism of the proposed offline payment solution? How does it integrate with the online payment?
Yeah, so it's actually the same transaction protocol. So whether we post these transactions instantaneously or whether the users wait days for them to post the transactions, it's the same mechanism. It goes to the private cluster of the bank that had issued them. And if there was an interbank transfer, it would use the interledger layer to reconcile with the second bank on that open loop system.
Okay, thank you very much. And now, ladies and gentlemen, let's invite the final team for the CBDC challenge. We have the contestant from C Labs. Gentlemen, ladies, over to you, please.
Hi, thanks for having us. My name is Jackie Bonans, CEO of Valora, and I'm joined by my partner, Ezekiel Kopik from C Labs. If we go to the first slide, I'd love to introduce you to Valora. Our mission is to unlock access to financial opportunities so everyone can create and share value without barriers. We see the opportunity to empower people and to give them control over their financial futures and to make digital currencies easy to use in a world where it's not. If we go to the next slide, I'll tell you a little bit more about what Valora is. So Valora is a mobile crypto wallet that enables global payments and easy access to decentralized finance apps. We're super focused on making crypto and digital currencies not only accessible, but easy to use. Our goal is to bring all the benefits of digital currencies to more people around the world in one easy to use app. If you please go to the next slide. The main obstacle for mainstream adoption of digital currencies is a lack of intuitive public key infrastructures. And really what we're doing at Valora is that we improve the user experience without compromising security. You might be wondering how Valora does this. And so one of the key ways that Valora does this is that we're able to map back a user's phone number to their public key address in a secure and private manner. And this enables the user to send funds to virtually any phone number, replacing the 42-character key. This is important because long public keys, as you can imagine, are hard to remember and easy to mess up. And with Valora, all you need to do is to know the other person's phone number to be able to send funds to anywhere around the world. This is a unique innovation that the Celo blockchain pioneered that Valora fully utilizes. So something really important to know. If we go to the next slide, I'd love to discuss how Valora not only makes digital currencies usable and accessible, but also how Valora makes it a safe and easy user experience. So the first point here is Valora supports the recovery of lost funds without compromising user identity. We've utilized an implementation of a secure password cloud backup option for account key recovery that simplifies the backup process without compromising user identity. The second point here Valora protects personal data while preventing illicit activities. We impose transaction limits to guard against illicit financial activity risks. KYC compliance measures must be met before lifting this restriction. And we also implement identity verification solutions that allow monitoring, detection, and prevention of illicit activities. One other thing to note is that Valora is fully decentralized because we're built on Celo's blockchain. And due to this decentralized nature, this means no third party stores personal user data. And then the last point that I'd like to make about Valora is that we leverage existing payment rails while keeping costs competitive. And so, what this means is that users can exchange crypto with fiat and leverage existing payment rails, utilizing Celo as an open ecosystem and a payments platform. If we go to my last slide, I'd love to cover how Valora is already being used by thousands of people around the world today. One of the use cases for Valora is that it's a tool for circulating unconditional basic income through a program that our partner runs called Impact Market. Since September 2020, more than 20,000 beneficiaries have used Valora to safely and securely receive this unconditional basic income. These recipients receive 50 cents to $1 a day. So these micropayments are possible through blockchain. And they use these digital currencies to pay for basic necessities in their communities. Some of the emerging behaviors that we've seen are users obviously spending this to pay for basic necessities, but also using the opportunity to save their currencies within Valora as a stable currency. And interestingly, we've also seen merchants use Valora as a way to receive these payments from the users that are receiving this unconditional basic income. This is a way for them to transition into a cashless business, and it's been amazing to see digital currencies circulate within these communities. This program using Valora has grown with Impact Market processing almost 6 million in digital currencies to about 20,000 beneficiaries in more than 20 developing countries, including Brazil, Ghana, the Philippines, and Zimbabwe. Pretty amazing to see because many of these users have never used digital currencies before, and it's their first time ever touching or holding crypto. We're proud to say that Valora is the way that makes digital currencies accessible for them and easy to use, and all through a tool that they already have on their mobile phones.
Thank you.
And
time is unfortunately up, but good news is we are moving over to the questions from the judges. Dr. Patrick, we'll start with you, please.
Thank you. Very good presentation. Controls secure. That's good. But the question is, do you see any potential here for supporting future growth in the ecosystem, future expansion in the ecosystem? Because it looks a bit too static. Thank you.
Yeah, sure. So hopefully you can hear me. I mean, we definitely, one of the things that we're trying really hard to do is to build our ecosystem, not only through Valora, but also the Celo ecosystem. And we're doing that by partnering with fintech companies, with traditional companies in local communities all over the world. And obviously the process takes time, of course, but we want to make sure that we're reaching out to local communities, working with their own startup enterprises, their own fintech companies, to really help understand like what their needs are locally as well.
All right, Professor Kenneth, why don't you take the next question, please?
Sure. So am I to think of your app as an off-chain crypto service in a way, and why is crypto essential to what you're doing?
Sure. I mean, it's an on-chain. So we use the Celo blockchain protocol. And so it allows someone to have access to any sorts of digital currencies. So whether those are cryptocurrencies, like the Celo native token, or stable coins, the Celo universe has a stable Celo dollar, which is pegged to the US dollar, and a Celo euro, which is pegged to the euro. We are working on integrating other cryptocurrencies such as Bitcoin, but certainly once a central bank digital currency, for example, comes along, there's no reason why that couldn't be integrated into the Valora wallet, or alternatively, the Valora wallet is an open source application. So a central bank or one of their technology partners could simply take that technology and use it and sort of white label it for their own purposes.
Tobias, last question, less than a minute. Please go ahead.
Yeah, very impressive. Thanks so much. So could a country that is adopting this put restrictions? So for example, one country might say, I don't want my citizens to use Bitcoin. Another country might say, I don't want my citizens to be able to transfer into foreign currency or so. Can you customize this for country-specific applications?
Sure. Yeah. I mean, so again, that would be, you know, if a central bank or one of their technology partners were to take the technology that, you know, the open source technology of Valora, they can certainly customize it to whatever their needs are, right? So they can integrate only those currencies that they want their users to have. I believe that there's also, you can sort of ring fence it based on the phone numbers that they have as well. So.
Yes. And time is up. Thank you, C-Labs or Cello. All right. And there we have it, everyone. The first ever 15 finalists for a CBDC challenge is completed. On behalf of MAS Tribe and all of our partners, we hope you've been able to immerse yourself in the solutions shown today. The finalists will be announced in the next few days, actually, at our annual FinTech Awards. So watch out. Thank you, everybody, and goodbye.